Now that we know how to leave numbers out of the domain, or how to figure out which numbers should be left out of the domain, now we're going to talk about simplifying rational expressions. The first thing to do is to factor your rational expression, and then you want to figure out which numbers have to be left out of the domain, and then any factors that are the same in the top and the bottom can be canceled out. It's a lot like simplifying regular fractions. But never ever cancel terms. You know, terms are separated by plus signs, and factors are multiplication. So you can never cancel a term. Make sure that the very first thing you do is factor. Only factors can be canceled. So here's our first example. Let's simplify x to the third plus x squared over x plus 1. So I notice that the top has a common factor. I can factor out an x squared from the top, and of course the bottom is a linear factor, so it won't factor at all. Now I look at the denominator and I see that the denominator cannot equal 0, therefore x cannot equal negative 1. And now I'm going to cancel out our x plus 1's, and so all we have left here is x squared, and we also note that x cannot equal negative 1 because that would cause the denominator to be undefined. Alright, new example. Actually, a couple here. Let's do x squared plus 6x plus 5 all over x squared minus 25. So the top, of course, is a trinomial, so we'll factor that into two binomials. First times first is x times x. The signs both need to be the same, and they both need to be positive. Last times last is 5 times 1. And the denominator is a difference of squares. So we'll have x minus 5, x plus 5. Now, note what has to be left out of the denominator before you start canceling. X minus 5 cannot equal 0. Therefore, x cannot equal 5. And x plus 5 cannot equal 0. Therefore, x cannot equal negative 5. And now we can cancel. Our x plus 5's cancel each other out, and we are left with x plus 1 over x minus 5, and we note that x cannot be 5 or negative 5. And now part B, we've got a trinomial in the top and a trinomial in the bottom. So let's just work on them one at a time. I know that the first times first has to be y times y. The signs need to be different. Now for 18, we could use 9 times 2 or 6 times 3, and if we choose 9 times 2, we'll be able to get our 7y in the middle. So let's let the 9 be the positive and the 2 be the negative. And then let's factor the denominator. Two binomials, y times y. The signs need to be the same, and they both need to be negative. And then the only way to get 2 is to put in 2 times 1. Okay, now, look at your denominator factors. Y minus 2 cannot equal 0, therefore y cannot equal 2. Y minus 1 cannot equal 0, therefore y cannot equal 1. Now we can cancel. I see a y minus 2 in both top and bottom, and I'm left with y plus 9 over y minus 1. And we note that y cannot equal 2 or 1.